Right, so let's look at this server code. Okay, so this server code pretty much a code for people to just try to get the file from the server, right? So TCP server, what's TCP stand for? It's a network, right? TCP, transmission control protocol, right? So this is all in networking. Like in computer science, you should understand networking too. So it's just like a request, right? I want to request, right? Let's look at an image. Send request. So receiver acknowledge that I received and send. So, and then it's just an acknowledge back to receiver, and then it's close communications. So it's just the way that they have to acknowledge, right? And then we start to send like the information, and then acknowledge back. Okay, this guy is just called TCP server, like to transfer the file, right? So this is pretty much just a file class to represent the file, right? And list of the files in the array, create an array of files, right? It's just called a folder because it could represent a folder to like C:/. And this is just loop to get the link and then show all the file name, right, in that folder. If it is a directory, it's also show the directory, right? All right, now this is called what? Method list file. Pretty much just list all the files and folders. The main pretty much just going to list the file, right? And then while it's true, so it's create a socket. So this is try to transfer the file through the socket, right? So there are many ways, right? So like what's socket, right? That's socket, yeah. In computer, maybe. Yeah, that's endpoint of two communications. So let's look at what's socket. A server runs on a specific computer, has a socket that's bound to a specific port number. The server just waits, listening to the socket for a client to make a connection request. Right. So on the client side, the client knows the host name of the machine on which server is running and the port number, right, on which the server is listening. To make a connection request, the client tries to lenders with the server machines and port. The client also needs to identify itself to the server, so it binds to a local port number that will be using during the connection. So pretty much just you create a connections between client server through the socket, and we just use a port number for that connections, like what it's virtual port. It's like the what's the port for?
Is it the router port number?
Yeah, like you have to open port number, right, from the firewall on the router. Yeah, that's a port number. Yes, but it's all virtual, right? Yeah, like this. If it's talk about TCP, right? So we use pretty much the IP address to locate the server, right, and the port number. And TCP connection can be uniquely identified by its two endpoints. That's why we just open a connection. A socket is one endpoint of a two-way communication link between two programs running on a network. Okay, it's bound to a port number so that TCP layer can identify the application. So in networking, we talk about TCP. You guys heard about TCP? Just if not just today, right? Transmission control protocol, right? So there are layers. You learn this in next, like in 205, little bits too. So OSI layers. Please do not throw sausage pizza away. Please physical, do data link, not network. Throw transport, right? Sausage session, pizza presentation, away application. That's how you remember. If you take networking class, this is gonna be first question. OSI models. There are 7 layers. That's why I have to remember.
The layer is the physical one, and just the top one is the application. Right?
Physical is the hardware, right?
Works.
This is the actual transportation of the data. Like you are at the application layer, right? When you try to send like data request, like we want to download the file, right? So we writing application at the application layer, right? And it's all called TCP, right? Protocol, right? So TCP pretty much you may see when you set up your router you have TCP and UDP, right? Right. So you have to set, right, and the IP address, right? So this is just all the networking, like how you're going to transmit data from source to destination. Okay, but if you look at your application, it's something that you cannot see and touch, right? It's all the data, right? But you're going to translate into the physical layer, like 0110 that transmit over, right? So that's why they have layers. So in this case, it's just create application, presentation, session, like start a session, right? And the layer transport, right? So pretty much it has a packaging. Okay, it's going to create a package, and this is a package for the protocol. Like now, we only look at the TCP layer, like application layer combined with presentation sessions all together. Like when you write an application, you have to create the sessions, right? And transport pretty much just link between two, host to host, and the network. And then this is go to physical layers, like are you doing the wiring between two, right, landline, or you do like Wi-Fi or whatever, right? Data link layer, physical layers. Okay, it's pretty much just the protocol that if you want to transport something, you need to follow this standard. All right, so again, a socket is bound to a port number so that the TCP layer can identify the application. That's the point, right? So TCP can identify, right? But now come back to, like, we're not going to go into that physical layer, right? So the socket, now this is an object-oriented programming, right? So this is represent the actual like that object socket, right? So we want to have the server socket. We create a socket and buffer output stream, right? So technically, this is try to connect connections now, right? So server socket, that probably the port number 3248, right? So we have the server that communicating through that port number, and we do accept, so we get a connection. So now when you look at, it's pretty much all Java under .NET, right? And .io. So if you look at like server socket class Java doc, so this is pretty much in the JDK library already, right? That you pretty much haven't used it yet, but we're looking at for what? Accept, right? Accept, right? So you guys see the method in here, right? Listen for a connection to be made to this socket and accept it. It's return the socket back, right?
Port number you put in it can be any number.
That you agree upon, right?
Okay, so
Like it could be the number that's still available and it's open, like because there's standard port number that will not be available, like 8080. That's for the web. For HTTP, like for TCP is what? For FTP is what? FTP port number is what? It's standard. These are like standard 20, 21, 22. You cannot use that because it's not available. For SSH, it's gonna be port number. Secure shell is they use 22, right? I mean, this is just standard port number, right? So now this is just use this one. You can set any port number that's still open, but you don't want to use the one that already, reserved for those, right? Now, so you get the socket back. Buffer output stream, you already learned this in 201, right? For the file transfer, right? Get output stream. Now this is what you want to send to client. Pretty much send a file, right? This is a file that we want to try to send. All right. So if the out to client is not null, then we make the file name, right? And then that's pretty much the location. This is pretty much just in 201 you learn how to connect to the file, right? Use file input stream, try to connect the file, right? And buffer input stream, use buffer input stream. Now we start to read, right? Read the file and write to out to client, right? So this is pretty much everything into out to client and close, right? When we open the connection, we have to close, if you remember that, and we close the connection socket. So that's pretty much how you transfer, right, through the socket. Now client, how would client request? There you go. You have to specify and create a socket again with what? The server IP address and the port number, right? This is just local, right? And then get input stream. Right, now you probably get input stream already right there. Dot get input stream. Now you download the file into IS input stream. Okay, and then if it's not null, so you try to create file output stream, buffer output stream, you create new file output stream. So this is write to the file, right? That is ss.java, the one that you read, you write to this file. and then you start to actually read and put into the bytes read, right? And keep writing the data, and then close when it's done, when all of them are written. So that's just how you transfer very simple to what socket. That's one way, but I think for her, she didn't use socket, she used REST API, right? So we just look at the basic. That's just basic, like transfer the file. Make sense? Using the socket, right? But there are many ways to do that. Doesn't have to be socket, right? So let's look at socket versus REST. Okay. So first, I think you have to understand REST, right? They have RESTful. Let's say REST API. What's REST API, right? So what you know, and this is a very brief explanation of can be very complex topic. That's true, okay. A REST API defines a set of functions which developers can perform requests and receive responses through the HTTP protocol. Alright, so one thing, we didn't use TCP anymore, right? This is different protocol. Socket we use TCP, right? So this is HTTP, right? So they can be used by practically any programming language and easy to test. Requirement REST API that the client and server are independent of each other, allowing either to be coded in any language and improve upon supporting longevity and evolution. So REST protocol architecture to provide a hypermedia-driven interface for websites. Okay. Let's look at Twitter provide REST API, which you can query to get the latest tweets. You can provide search query, and it will return the result in JSON format. So JSON is just a format of the data. It's very simple. Everyone know JSON already? No, right? Okay, let me show you then in that case. So it's very simple, like think about how am I going to exchange the information between server and client, right? It's two different machines. Your client could be your phone, server could be Twitter server. We talk about Twitter RESTful API, right? So you just put into a JSON like, look at, I create a variables named my object. My object has the attributes name and the values John, another one age, right? 31, city, New York. So how am I going to package this and send data over HTTP, right? So it just make a JSON object. It just use stringify, right? Stringify, pretty much a function that pretty much convert everything. This is an array, right, of data into a JSON object. Okay. Convert object into JSON and send it over to the server. Right, and then you can just attach into your like this, the URL HTTP protocol at the end. Last time I showed you how you attach, like get parameter, right? So the data actually attached into the HTTP on the top right here, right? When you do request and response. Everyone understand that part, or we have to see it again? Are we good? We good, right? I mean, you probably want to understand this, then you can do your project, right? For the when you talk to API, right? So this one pretty much just showing, this is simple HTML page with the JavaScript that you create a JSON object, and then this is just simple JavaScript again to display. This is client, right? You create an object, right, using stringify, right? And then it looks like you just, this is like this structure called local storage, right? You set that object into that. It's just like what a map. It looks like with a key and the values, right? So now we put in the data structure. How you going to put it back? Pretty much just get items, right? This is like set, this is get with a key, and then you get a value back. And then you just do JSON parse, get back into object. And then if you want to get the attribute name, you just do object.name. Then you get a value back. Like if you do object.name, right? So object.age, right? Maybe put some, just put tab to it. Right, John 31, see that? So you get the data back. They just try to show you how to use just stringify. And this is just how you display. You just say, hey, this is demo document. That means this document I want to display by get the ID. This ID is demo, and just show the information into inner HTML. This is JavaScript. Okay. This is just on the client side, right? Now you understand JSON. Just try to show you what's JSON, right? That's the point. So the JSON pretty much with the curly braces, right? You give the name and the values, right? So that's a JSON format. Okay. Now we understand that. We come back to, now we understand what JSON. Now we come back to what's REST API, right? If we return the result in JSON format, like there's JSON object, pretty much, right? So I want to get the latest tweet matching the jQuery. So this is pretty much just the HTTP that attached to that to get the latest 3 tweets. So let's see. Let's just try this test a little bit. Is it a real? Yeah, I try to request that, but there's an error. It's no longer active. That's version 1. So that's no longer valid anymore, right? So if it's valid, just return information back. That makes sense. All right. So now that's pretty much the REST API. You just send in and then you get the data respond back. So the REST API should specify what it can provide and how to use it, like parameters, response format, limitation or request, like public key or API keys, right? Get, post, put, delete. That's pretty much just like your data structure, right? So this is just the Twitter API, right? That's version 1.1. If you want to use, you require to register to get your API key. So this is pretty much just REST API, right? Now, what's REST? REST stands for Representational State Transfer, which essentially refer to a style of web architecture that has many underlying characteristics and governs the behavior of client servers. Okay. What can you use a REST API? So you interact with parts from anything that can send an HTTP request. So we have Twitter, Google, Facebook, and so on. Doesn't exist anymore, huh? Let's see, Facebook REST API. Right, so if you want to get some information, like this is just talk about graph, which is related to our data structure last time, right? You want to use graph, right? Get data in and out of Facebook socials graph. So this pretty much is going to show you, this is JSON, right? JSON format. You can specify ID, name, pictures, and then it's going to return, right? Graph API call using your own user access token. You probably have to register first to get your API key. It's going to return ID, name, picture of, pretty much return your profile. Like if you have Facebook account, you try to use that, it's return your profile, meaning what? You can get the data to set on your application now, right? Like now, what we try to create a project, we try to get the person information, which is the profile, right? We want to see what they like or whatever, then we can make that information and can create a node and make a graph. This is a good one to look at to get a profile, right, of the users. So now if you really think about your project even further, like now we only make it simple. You create an account, right? Based on that account, you create a node and make a graph, right? Based on like the food that you like, right? But if you can actually use Facebook API, you can actually get the profile of other users that friends to you, and then you probably don't need that Excel sheet anymore. You can construct a graph and nodes in there, right? Make sense? You can just put the data to create your nodes, right? Okay, so that's another example. So now what is meant by the term RESTful API? Conforming to the REST constraint is generally referred to as being RESTful. An API can be considered RESTful if it has the following features. Client server. The client handles the front end, the server handles the back end, and can both be replaced independently of each other. Statelets. No client data is stored on the server between request and session. State is stored on the client. Cacheable. Clients can catch response, just like browsers catching static elements of a web page to improve performance. Right, have a cache memory, right, to store some data, right, to make it faster. So complying with this constraint and thus conforming to the REST architectural style enable any kind of distributed hypermedia system to have desirable emergent properties such as performance, scalability, simplicity, modifiability, visibility, portability, and reliability. So I have seen this, and this is called RESTful APIs, right? Like this is an example. This is for Dropbox to copy, create folder, delete, and move. So the architecture of RESTful client server use the internet media types. We have the URIs, request and response codes. That's why we try to say request and response, request and response. But we were looking at simple code on the socket, right? Client request, server response. But this is different. This is REST. Allow existing layer, proxy, and gateway components to perform additional functions on the network, such as HTTP caching and security enforcement. Now you can create a RESTful Web Service API. It's pretty much just like, for example, a collection of resources like we've seen if we want to get the data, right? So this is /me/photos. So this is how you can get the data, provide field ID, name, pictures, right? So that's an example, right? Now the format, right? This the intermediate type of data support by the web service. Okay, they have the web services too, and web services normally is going to be XML format. It's very common. So what is that, right? So like when we get the data, it could be in JSON, XML, or YML, right? So that's the response on the data format. Like I just show you the JSON. And of course we still have the same like operation support like post, get, put, or delete. So this is a request format, right? Now in the web service we call SOAP, right? The popular REST API response format now is JSON, the most popular one. So let's look at like SOAP, Simple Object Access Protocol. It's use XML format. Let me see if they have. Yeah, this is a structure of the SOAP. So you have the message, you have the envelope, header, body, sender, receiver, path. So SOAP structure is just like that, header, body. So this is an example of the format in XML. This is SOAP. Like this is stock name, Google. You try to get the stock price, right? So that's the example. Do I need an API to access REST API? Yes, most of them has the remits like on the request when you write. Otherwise, you keep asking for a lot of data. So that's why if you want, normally they ask you to pay for, you have to limit access to like how many like bytes a day, and then if you request more than that, you just have to pay for, okay, for the data. And yeah, the data sensitive API will require you to authenticate, and the most popular method is open authentications, OAuth. And this is like, yeah, like that example of the Google API that you need to provide your API key to get, right? Is it a REST API or just an API? So how to decide this? You will have to study the documentation and determine if the API certifies it. And there's Atom API is a good example. Okay, I think that's pretty much it for now. Yes.
Just have a funny story about API. So we were using me and Olga were going to one hackathon in Baltimore, and we were using Google Search Engine API, and we were using our API key. And the funny thing was that it was a limited time of you requesting. So every time we get out of the limit, we have to create a new API key. So we were creating new Google accounts.
Yeah, there's a limit, right? All right, so in your final projects, that's why let's talk about part 4, right? So last time did we finish graph already? We talked about graph, right? Did we finish? I talked about node and right. So okay, let's look through this. We can go back and review that part. So instead of hospital, we're gonna find what? Instead of hospital, we're gonna find what? Person. That's right. friends person, right? So you're gonna find person nearby, right? So from assignment 3, you already have ability to search a person, right? Based on the criteria that you provide, right? Now, we actually, just like she has presented a little bit, right? On instead of person, she did the hackathon nearby, right? So instead of returning the list according criteria, right? You actually going to talk about nearby instead, right? So, and we want to use graph, right? So the algorithm say, since we're gonna have to base on geolocation, like the latitude and longitude, right? And each person coordinates, right? So we have to use what? Since it's not a flat, the distance is not going to be from x and y and subtract, because the Earth is round, right? So that's why we have to use the Hilbert's formula to get the accurate distance. So add the radius parameters to allow the user to set the radius of the person nearby in miles. Use the difference distances from your location to person nearby within the specified radius. So first, we're gonna have a lot of, let's go back to let's go back to our, we have the emulator or the web interaction that we create a graph, right? So let's go to graph. I want to get to that link. I think we can search by link. Graph learning tools. Here you go. If you remember, we were talking about this algorithm last time, right? We create, right? So this could be the constructed graph already of the person, right? Person 0, person 1, 2, person 3, right? Okay. And we could have more person, right, with another group that we create a graph, and we know that they are related based on if they like the same food, right? That's what we were talking about, right? Now we construct this graph, right? We construct this graph too. Okay. So now we have to find the distance. Like we gotta add the parameters, right? So now, I mean, for your object, you already have the coordinates, right? Lat long, right? For each person, right? Then, so assume that 4 is you, right? Your current location. You want to find the person nearby you. So we're gonna have a parameters that add like maybe 5 miles, 10 miles, right? Radius, right? Nearby you. So let's say this is about 5 miles. So you have to use the coordinates, your current location, right? And find the difference between, right, this radius, right? 5 radius nearby, right? Something like that, right? Make sense? And then you can add more criteria like, okay, I want to find a person that nearby me and maybe like the Mexican food, right, in this radius, right? And assuming this is the Mexican food group, right? So it's going to start to show 5, but the distance you use the hover sign, right? Now, how do we do that, right? Like, if you think about, we may have so many groups, right? Nearby, right? How do you know that 11 and 10, who is going to be closer? Right. So that's why you have to, because nearby 5, remember 5 mile radius could be a lot of people now, right? In this case, correct? So that's why you're going to have to find the hover sign, the difference, right? Distance from your location to everyone here, right? That makes sense? Okay. And then you gotta list what? You create a list. Use the add the parameters to allow the user to set the radius of the person nearby in miles. Or use the difference distance from your location to person nearby within specified radius to create a min heap. So if you remember min heap, you guys remember heap? You can use heap to sort, right? So that's why we use, normally if you do max heap, it's going to sort from high to low, right? The top of the root always the biggest number. So when you do min heap, then we just get what? Low to high. So that means after you put all the friends in 5 miles there in the heap, it's already sorted for you. Correct? Because you used min heap, right? And then you can display the list of person within a specified radius, ordered by the distance that's closer to you, right? From min heap. That should be easy, right? To create for this one. Make sense? So the different distance value is used for the order of the priority queue, right? We use priority queue to create a heap, right? If the children of the root of the priority queue has the same distance difference, then the children must also be displayed on the person nearby list. Pretty much, if you have the same value, so we allow duplicates, right? Alright, so now we're done with that part 1, right? 4.1. Now let's look at 4.2. So construct person graph. 4.1 pretty much just want you to use heap, right? 4.2 you're going to construct person graph. pretty much these are the graph, right? That we have to construct, right? But we don't use the nearby. We use what? Like for example, hackathon. They like hackathon, right? Or food, right? Using the person, we could construct person graph by using the, what do you call that? The person favorite. Yeah. Favorite food. Okay. Like I said, you can always replace, like she wants to do hackathon, then just do the hackathon, right? Or you want to do any criterias. I love music, pops, right? So just, this is just example. I use food, right? As a criteria, you can always change the criteria based on the user object, right? So the vertices are constructed using each person from the list. So these are the vertices or the node, right? So these are the person. So it's construct from the list that we already know have the list. The edges are construct from the different, no, from the what? From the similarity, huh? Of favorite food. Right. So we construct the edges. So like 11, 12, 13, they love Mexican food. So 5, 6, 7, they love American food. Right. 0, 1, 3, 2, they love Korean food. Right. So we construct edges are construct from the similarity of favorite food. Right, from the current to the nearby person. I think you can just start from just how do you construct then? So you, like now we have the list of the people from what? Excel, right? So you start to lead one by one, and then you start to construct them. Create a graph based on the food criteria, right? Some of them may not be linked because different, right? Make sense? Now, construct graph from the, we're going to talk about, you have to use this now, DFS and BFS, right? Breadth first search and depth first search, right? So again, what's breadth first search? When you search from what? Starting vertex, right? Let's see. It's just expanding out like that, right? So let's say if I create more nodes like that. So we gotta do this way first, and then. But if you depth first search, let's say. So depth, like for example, if I'm starting from node 0, right? I'm looking for 16, right? I have to go 0 to 1, 1 to 15, 15 to 16. So go by depth and never go to 2 and 3. Okay, but if I go to 2, I'm not finding it, then I have to go back, go to 1, go to 15, and go to 16. This is called depth, right? But breadth is actually go to 2, go to 1, go to 3. I'm not finding it. Go to 1, go to 15. Like if 15 has something else, it's going to go to 17 first, right? Now if I'm not finding it, then I go to 15, 16, and I found it. It's like spreading around the nodes. Visit all the neighbors first. So that's called breadth first search. But depth first, once you go one path, you keep going down until you cannot go anymore. Then you go back and keep going down. You go back until you found, you stop. Make sense? Okay. So after you construct the graph, right? So you have a group of people who like the same food. Okay, and you have yourself, right? Let's create more people right here. Now, you are going to search, I want to hang out with people who like Thai food. You have to look around in your radius, right? And then you're going to have to find the group of people. You start to look at this guy. This guy is, no, this is Japanese food. Nope. This is Mexican food. Nope. Now I found, oh, this is Thai food, right? So you're pretty much going to do what? Either use breadth first search or depth first search. But from yourself as a node, right? Make sense? Right, so because this is another type of data structure, right? If you really think about, if you do list, you want to compare 1 to the n, it's going to take forever for the world populations. But if you use this technique, it's probably going to be faster based on locality, based on nearby first, and then based on, right, depth first search, breadth first search techniques, right? That makes sense? Okay, so this is the part that we were talking about here, right? Construct graph from my location to person location, right? Using breadth first search algorithm to find person who has but the same food type, the same favorite food as your. Construct graph from my location to person location using breadth first search. I'm going to find person who has the same favorite food as your person nearby, right? Okay. Now you probably want to add what, or even like a search key that you did on the assignment 3 to key in like Thai food, Japanese food, or whatever criteria is, right? To test to see it works, right? So this is just pretty much just resources for the how you get the what geonames.org return zip code nearby within 10 kilometers by latitude and longitude if you need them, right? if you want to look at zip code, but you don't have to. And this is the zip code API. Find the shortest path. Alright, so now once you found the person, right? This one I only require you to do breadth first search. I didn't ask you to do depth first search. So now, when you found, okay, let's look at this again. Alright, so I may, instead of finding Thai food, I may want to find someone who loves French food, right? This is a group of French, right? So I'm going to construct a graph from my own node, right? How am I going to link to French? Let's say I start to be French. Maybe this person also, this Mexican food also like French, right? So I construct that graph too, right? Or this person maybe like happen to know this person 19 no 24 they like French too, right? Find the shortest path to the French group. Like say let's talk about find shortest path, right? Before we talk about find a group using breadth first search, right? Now we find a group, but I want to visit that person now after you found it. Right, I want to visit that person. How do I visit that person? Since I don't know this guy is my stranger 24, right? But I happen to know this guy. This is my friend 14. And 14 happen to like Thai. And 14 happen to know 15 who like Thai, which also like French. And 15 happen to know, is it 19? 19, right? 19 happen to know 24 who like French too. I can actually visit my Thai friend 14, and then my Thai friend can just introduce to 19 and bring me to 24. That makes sense? Or the other way around, right? I happen to know my friend 13 who like Mexican, and my friend 13 know 11 who like Mexican, and 11 knows 12 who like Mexican, and then 12 knows 20 who like French. So which route will actually take me to get to French group the fastest route? Okay, or 13, 11, 12, 20. This is called the find shortest path. Because it could be many routes, right? This is just example of 2 routes, right? Because in reality, that's how people know each other, right? You introduce by, you go out because you like the same thing. Now introduce your friends, right?
It's the shortest path which number of people, doesn't depend on the distance in between, like the physical distance between 2 people.
Yes, it's physical distance here, right? Remember we used the my radius, right? To construct a graph.
But you use the radius to get to 14, right? But then when you go to 24, you use the number of people who know each other, right?
Yes, and we also look at 1924 distance too, right? I mean, we link them because they know each other through the favorites, right? That's how we connect to them. But now, how to get to visit this person? We're gonna count all the shortest path based on the distance. Right? Like you may have your friend who live in Japan, and you have your friend who live like in Annandale, and your friend in Japan knows a person who loves French, and your friend in Annandale knows a person who loves French. Then you probably want to visit Annandale, not Japan, right? Like we want to find a shortest path to get to know the person who love French, then you can just go and get the best French food. Remember, this whole thing is what? Recommend the best French food. You want the best French food, who you want to go? Japanese food group? You have to go to French group because they're going to eat French all the time. We're going to talk about the best French food. And how will I know that person? I want to find a charted path to know that person. That's what you have to implement. Make sense? I mean, this is a little bit smarter than the way that we used to do. The way that we used to do, we just go and maybe stop by, looks good, this restaurant, good review on Yelp. But this is based on recommendations system.
So the path is weighted as in distance? We're looking for the shortest
Yeah, we only make simple criteria. Like criteria can actually change to anything, right? But now we're looking at just how we can make shortest distance. Yeah, miles, right?
But what am I worrying about? Like from distance between physical distance between 4 to 24 is always constant because it doesn't matter which way you go, 4 to 14 or 4 to 13, then go to 11, 12.
But 4 to 13 could be shorter if it's like 1 mile and 1 mile, 1 mile, 5 mile. That 5, 6, 7, 8, right?
Yeah, but
Now, think about how would you get that? How would you get 8?
you get 8.
You probably going to do what? Depth first search or breadth first search. And then you just accumulating your, whenever you walk, you add. Whenever you walk, you add. Right? Now, this could be 4 to 14, could be 1 mile. 14 to 19 could be half a mile. But 19 to 24 could be 10 miles. Then the charted path, actually this path, right, on the top. Based on what? Location, again, geolocation give you the distance, right? Distance from this guy to this guy, distance from this guy to this guy. We talk about statics, geolocation. We're not counting this guy keep moving.
Do we have to make our own graph?
Yes.
Data structure.
You're gonna have a lot of graph here, right?
We have to make our own data structure for graph like that, like just we did.
Yes. And now you have to write your own application based on the graph that you make. That makes sense? You're gonna probably use your graph for every group, right? You're gonna create all the instances of your graph, right? Like several graph data structures, right? And then you create your own graph to find the charted path. That's another graph. Based on distance between you construct a new graph with the criteria that you provide by looking at other people's graph, right? So that's what we try to explain in this document for your final part of your project. Right, find the charted path, right? Right, based on the same criteria, right? Of like favorite food, right? And what? And shortest distance. Okay? Correct? And this is pretty much just resources. Extra credit. You can, like I said, you're not required to actually physically have an image of the nodes and graph. But if you have, then you get 10% more. Let's say 20% more, better, encouraging you. We probably want to use Google API, right? Google Map. Now, we have learned what charted path, right? They also have the ant colony. This is another data structure algorithms based on the ant. Look at ant when they try to find a sweet.
Instead of using graph.
Both. After graph, you create another ant. When ant looking for sweet, how could they find a sweet?
Stuck to another ant.
They actually keep all the ants out, right? Once, how do they know that once they go to that path, they will not go again? Alright, so we're gonna talk about that next time. I think it's about time. So this is about that, and then we're going to finish up the facet.
So, like, what's our product gonna be like? Cause it's too cold.
It's very similar to midterm.
But it's too close to it.
Hmm.
Like, why is there two parts to the final instead of one like you did?
Oh, I just separate into two parts.
Okay.
Yeah, one is for student learning outcomes to measure.